Okay, so good day everyone. In our today's sessions, we're going to discuss another method on how to add a vector. So in our previous discussion, we already discussed about the addition of vectors using the graphical method. So in our graphical method, we can use a parallelogram method and a polygon method. So this time, we're going to proceed to another way on how to add a vector, which is by using analytical method. So in our analytical method, we're going to apply the mathematical concepts like the simple geometry, the simple trigonometry, and the algebraic expressions. So in our analytical method, we're going to use the different methods such as the algebraic method, the triangle method, and the component method. Okay, so let us have first the algebraic method. So this method is used when you add the two or more collinear vectors. So when we say collinear vectors, these are the vectors that lies or that acts on the same line or on the same axis. So take a look at our given example. So in our examples, as you can see, the three vectors are all lies in our x-axis or horizontal axis. So this is an example of the collinear vectors. Okay, so the vector A, it measures 20 Newton due to west. The vector B, it measures 45 Newton due to east. And the vector C, it measures 50 Newton due to west. So how we're going to add the three vectors or these three vectors using the algebraic method. So just simply get the resultant vector. So to get the resultant vector, just simply add the vector A plus the magnitude of the vector B plus the magnitude of the vector C. So let's substitute the given magnitude. So in our vector A, so since our vector A is lies in our negative x-axis, therefore it can be expressed as the negative 20 Newton plus the vector B. So since our vector B located on positive x-axis, therefore it can be expressed as, or can be added as positive 45 Newton. And lastly, the vector C. So since our vector C lies on the negative x-axis, which is our best, so therefore it can be added as negative 50. So to get the resultant vector, just simply add this three magnitudes, so negative 20 plus 45 plus negative 50, that would be negative 25 Newton. So since we are dealing with the vectors, which define as the quantities that has magnitude and direction, therefore we must get the direction. So since our magnitude is negative magnitude, so therefore the direction of this resultant vector will be due to west. So the final resultant vector natin will be 25 Newton due to west. So therefore, this is our final answer. Okay, so our next examples will be the vector A, it measures 35 meters due to north, and the vector B, it measures 60 meters due to north, and the vector C, it measures 55 meters due to south. So as you can see, our three vectors are all lies in the same axis, or the three vectors are all collinear vectors. So since we are all lies in the same axis or same line. So to get the resultant vector, just simply add the three vectors. So we have the vector A plus the vector B plus the vector C. So let's substitute the given magnitude of each vector. So in our vector A, since our vector A is located at north in our direction, or our vector A lies on the positive y-axis, so therefore it can be expressed as the positive 35 meters. Plus the vector B. So since our vector B located at north or plotted at the positive y-axis, therefore it can be expressed as positive 60 meter. And the vector C, since our vector C is located at the south, which is lies or plotted into our negative y-axis, so therefore it can be expressed as negative 55 meter. So to get the resultant vector, just simply add all the magnitudes. So therefore, we have 35 plus 60 plus negative 55. The magnitude of the resultant vector will be positive 40 meters. So to get the direction of our resultant vector, so since our magnitude is positive magnitude, therefore our directions is due to north. So our resultant vector will be positive 40 meters due to north. So that will be our final answer.